Hello everyone. Once again welcome back to the lecture series on thermal aspects in metal cutting. In my last video I was discussing about the tool wear. Wear is nothing but the loss of material from the surface of the tool, so which will reduce the life of the tool. So here in today's video we are going to discuss about the two different types of wear which will takes place in the cutting tool. So first one is the flank wear and second one is the crater wear. Now what is flank wear? So if you see here, I have named some of the parts for a single point cutting tool. If you know the nomenclature of single point cutting tool, then you can easily identify the different names. So here this edge is called as a side cutting edge. This edge is called as a end cutting edge. Below this edge there is a face which is called as a minor flank, and below the side cutting edge there is a one more face of the tool which is called as a major flank. So here what will happen during the cutting operation, when these faces of the tool comes in contact with the workpiece, some rubbing action will take place, some scratching action will take place, or friction will take place, due to which the temperature will get rise in the tool, and due to high temperature some loss of material will take place from these surfaces, that is from the flank faces of the tool. Some loss of material will take place, and this loss of material which appears on the flank face of the tool, we are calling it as a flank wear. Now what are the major factors which are contributing for the flank wear? So the flank wear, factors causing the flank wear, first one is the high cutting speed. Definitely when you increase the speed, the friction will get increased, the temperature rise will be there in the cutting tool, due to which the wear will takes place. Increasing the depth of cut and feed, so this will also increase the chances of flank wear. Abrasive action is nothing but during machining operation or during cutting operation, some of the powdered particles may get stuck between the workpiece and the cutting tool, due to the presence of these powder particles, they will act as abrasive particles. Abrasion is nothing but it is the scratching action. So these powdered particles will act like abrasive particles, and they will start scratching the faces of the tool, and these faces which will come in contact with these abrasive particles, those are called as a flank faces, and therefore there is a loss of material which will takes place on the flank face of the tool. Adhesive action is nothing but some of the microchip particles may get stick to the workpiece or may get stick to the tool material, cutting tool. Why this sticking happens? Because due to increase in the temperature, when the temperature between the workpiece and the tool increases, so it will create, or the microchip particles will get welded to the surface of the workpiece and to the surface of the tool, and the presence of these microchip particles again lead to the formation of flank wear. So therefore these are the some of the factors which will cause the flank wear. And if you want to reduce the flank wear, definitely you should use an appropriate cutting speed. You should not increase the depth of cut or feed rate, and you should avoid the abrasive and adhesive action by using proper coolant, and by flowing away the particles, that is the powder particles, from the surface of the workpiece and the tool material. So this is about the flank wear. Next let me discuss about the crater wear. Now what is crater wear? Crater wear is nothing but the wear or the loss of material which will takes place on the rake face of the tool, that is on the top face of the tool, way over which the cutting chip or the chip will flow over that surface. That face we are calling it as the rake face of the tool, and whatever the loss of material takes place on that face, we are calling that wear as a crater wear. So crater is nothing but it is a ball shaped cavity or curved shaped cavity which will formed on a particular surface. For example, if you see the structure of the moon or the surface of the moon, due to the striking of asteroids and meteoroids, at some of the surfaces you can see the formation of a cavity. Those cavities are called as a crater. In the same way, on the tool rake face, due to scratching action between the chip which is flowing over this surface and on the rake face, so there will be a friction between the flowing chip and the rake face, and even when the chip is flowing, some of the chip particles will get stick to it, which are called as a built up edges. So these built up edges may also lead to the formation of a craters on the rake face of the tool. So this is the crater wear, and the factors again which will lead to the formation of a crater is, first one is the friction, second one is the built up edges, coolant, speed, feed and depth of cut. You know that when the friction between the chip and the tool get increases, definitely the temperature will get increases. Due to this high temperature, the wear may takes place on the rake face of the tool. Built up edges, so when the chips are welded with some of the small chip particles, and these chip particles will rub against the face of the rake face of the tool, which will cause the crater wear. The coolant, if you don't use the appropriate coolant, then again the coolant may not carry away the maximum amount of heat, and due to the poor coolant, so the temperature rise will be there, due to which again the crater wear will occur. Cutting speed, increasing the cutting speed, feed or depth of cut will also increases the chances of crater wear. So it is better to use the best available coolant to avoid the crater wear. It is better to use the means you should avoid the built up edges. The formation of a built up edges you can avoid to reduce the crater wear. So this is about the types of wear which will occur generally in the tool part during a cutting operation. Thank you very much. Thank you for watching this video. Keep watching the videos and wait for the next video. Thank you.